Okay. So the first one says, which of the following represents the equation of y equals square root x once it has undergone a horizontal translation 4 units left? So when anything goes from words into equation and it does something to the x, it does the opposite, except for reflections. They just negate it, right? So if we want to move 4 units left, we're going to have to go y equals square root x plus 4. And then a vertical translation 3 units up, plus 3 to the back. So if I want to move that over, it's a minus 3. It's D. You don't have to move it over. Number 2, the graph of y equals f of x is transformed the graph of this. So words and mapping are the same thing. This is a horizontal translation 3 left, vertical translation 2 down, or in mapping, x, y becomes, how do I move it to the left? Minus 3. How do I move it down? Minus 2. So I always write out my options and then match which one works. Which one works? C. Numeric response 1, as a result of the transformed graph. So this one here is just a function f, and then it has a little f in it, right? So this gives me the transformations. Remember when the f is in here, it's just another way of saying here's transformations, do stuff to it. And then here's this. This one is a cubic to a cubic, so I have to compare them. This cubic has absolutely nothing on it. So it's moving from a cubic with nothing on it to a cubic with stuff on it. So I have to say what happened. So we have x minus 3 cubed plus 4, so the first thing I always do is move it all to one side set equal to y, and then I'm moving a coordinate. When I move a coordinate, I use mapping. So I'm going to get xy becomes x plus 3, because I'm moving it 3 to the right, and y plus 4, because I'm moving it 4 up. So I put in 3 and 27, and I get 3 plus 3, and then 27 plus 4, which is 6 and 31, and which one did they want? Y. So 31. Number 3 says the range of this function is greater than or equal to negative 11. We're doing this stuff to it. What is the range? Is the range x's or y's? So what's going to affect it? X's or y's? Y's. So do I care that this thing's moving one to the left? No, the whole graph's moving one to the left, but it doesn't affect it because all I care about is my range. And my range is doing what? Going down 3. So where's it going to be at now? Negative 14. So now it's just greater than or equal to negative 14. We don't care about the x. It didn't do anything to it. Okay, then we're going to flip over to reflections. And like I said to you, you need to know these things backwards and forwards when they're apart, because once you put them together, it gets real messy if you don't know it. If you're like, I think you flip it, I don't know. If you're doing any of that, it goes really terrible real fast, because all of the common errors are on the multiple choice answers. So you can't narrow it down. Oh, good matter. Nope, that's today's. Here it is. Okay, so this one here is given the equation y equals 1/2 x plus 3, determine the equation of the function, a reflection in the y-axis. What does the reflection in the y-axis do? It affects the, sorry, it's x-axis. In the x-axis it affects the y values. So how you can do this is you're going to have a negative y. Instead of having a y, you're going to have a negative y. Which is great, except I want it in y equals. So how am I going to have to get it into just plain old y equals? Divide by -1 every term. This one is usually done poorly. Divide by -1, divide by -1, divide by -1. And I get y equals -1/2 x minus 3. Now you should know if you're right or wrong. Do either of these equations have x's in them? Is there any x in the equations? No. So can you type the original into your y1 and the new one into your y2, and they should reflect on the x? Yes, you can check them. So if when you type it in, it doesn't reflect on your x, you should question yourself and go back and try again. Okay? When it's a reflection in the y-axis, what does it affect? Your x value. So your x, instead of being x's, become negative x's, correct? For this one, your y became negative y. Became, not equal to. Okay? This one, your x becomes negative x. So the only thing that's going to change is this x here. I'm going to toss it out, and I'm going to replace it with a negative x. So I'm going to get y equals 1/2 negative x plus 3. So y equals negative 1/2 x plus 3. And once again, if you type this into your calculator and you type this into your calculator, they should now be reflecting about the y-axis. So you should know if you're right or not. Where would the invariant points be if it's just a reflection in the y-axis? If there's just a reflection in the y-axis. Nope. If there's just a reflection in the y-axis, all the invariant points are on the y-axis. What's the equation of the y-axis? X equals 0. Wherever x equals 0, you're going to get invariant points because you're multiplying x's by -1, right? And you multiply 0 by -1, nothing happens. For this one, when all you have is a reflection in the y-axis, or reflection in the x-axis, I really want to say y with that one. Reflection in the x-axis, where are the invariant points going to be? On the x-axis, which is what equation? You do. If this one's x equals 0, what's the x-axis? Y. So the x-axis is actually y equals 0 because it's where all of the y's are equal to 0. And your x-axis is x equals 0 because it's where all the x's are equal to 0. What is the order in which you have to state transformations? Do you remember? Cert. Stretches, reflections, translations. We agree? Just so you know, B, I don't expect not one of you to get it right. I set you up to start into today, but you'll see. So, for A, you're going to subtract 5, correct? Then we go stretches. We haven't learned any. Luckily, there's none on here. Reflections, are there any? Yes. There's a reflection with the x value. If there's a reflection with the x value, it means all your x's are being negated. Boom, 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 boom. So if there's a reflection with the x, what is it actually in? Yeah, it's a reflection in the y-axis. And then we have translations. We have just a vertical translation, because it's not with the x. 5 what? 5 units down. Okay, the reason why B I set you up is whenever we've done translations, any horizontal translation, we've always had a 1 in front of our x. And on Friday, I didn't even give you questions where there was a negative sitting out front to mess you up. Okay? What you need to know is in order to have your horizontal translations correct, you have to have a 1 in front of your x value. What do we currently have in front of our x value? A -1. So I'm actually going to have to GCF a -1 out. So I always have to have a +1 in front of my x in order for my horizontal translation to be right. So you all would say horizontal translation 3 left. It's actually 3 to the right. Because I need to have a +1 in front. This is why it's sending this home, little starting moment. So we always have to have a +1 in front of our x. So before we even start this question, we're going to have to go -f. And we need to take a -1 out so that I'm left with +1x. Do you see that? I'm going to take a -1 out of 3. What do I get? -3 minus 2. So if you forget to take the negative out, you will have the wrong horizontal translation. Everything else will be right, but your horizontal translation will be in the wrong direction. So make sure you take a -1 out and make sure you have a +1 in front of your x. So this has to happen. It needs to be a +1. If it's not a +1, you can't see horizontal translations. You're stuck until you make it a +1. Okay? So, reflections. We have a reflection with the y's. When it's with the y's, it's a reflection in the x-axis. When it's with the x's, which it's still with the x's, do you see how there's a bracket around here? That negative one is still with the x. And how do you know it's with the x? Because you could actually distribute it back in. If you can take it out or distribute it back in, it's still with the x. Okay? It's just not right beside it, but it's still with it. So that negative one is with the x, so I still have a reflection in the y-axis. Translations, what's this? Horizontal translation, 3 units right, which I set you up intentionally. And a vertical translation, 2 units down. Does that make sense? Do you see how you have to have that +1 in front? Star, 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 star. Honestly, the people who have their stuff down pat for the test, when the test comes, they know they're like, when I see a negative in front, it's a reflection in the y. When I see a negative in front of the y, it's a reflection in the x. I know what my mapping is. I know what transformations. Those people sometimes do poorly on the test because they never take the negative ones or the 3s out. They don't make sure that there's a 1 in front of the x, which sucks because they know their stuff really well. They just forget that one little step. So we're going to make sure that we remember it. There always has to be the key thing before you start stating mapping, before you start stating transformations or whatever, you will always look and see, is it in y equals and do I have a 1 in front of my x? If I don't, I need to get it into that form. If you do that, you're in a much better place than everyone else. Okay? So we're going to look here. If you look at C, I set you up again. So the point 110 is on the graph of y equals f of x. Determine the coordinate of its image point under the following transformations. So what I tell you need to do, you're moving a point, you need mapping. Point mapping. What we do. How do we do that? We get into y equals and make sure there's a 1 in front of our x, correct? So I need to move the 4 over. And I have a 1 in front of my x, don't I? So I'm good for this one. So my mapping is going to be x, y becomes, I have a horizontal translation 5 to the right. So I'm going to go x plus 5. And I have a vertical translation 4 down. So I'm going to go y minus 4. And then I can just plug in 110. And I get 1 plus 5, comma 10 minus 4. And I get 6 and 6. For B, I have to be in y equals, and I have to have a 1 in front of my x. I'm in y equals, and I have a 1 in front of my x, so I can go right to mapping. Mapping is the easiest if you remember this. Whatever's in the bracket with the x affects the x. Everything else side of that affects the y's, right? So is this negative with the x? No. So I'm going to get a negative y. Is this 12 with the x? Yeah, so I'm going to get x minus 12. So some people don't know whether they should put it with the x or the y. If it's in the bracket with the x, it affects the x variable. That's it. If it's outside of that, it doesn't affect the x. If you remember that, it makes life easier. So my coordinate is 110. And I'm going to get 1 minus 12, comma, negative 10. So I'm going to get negative 11, negative 10. What's the catch with C? You have a negative x. So, do I expect this to have been right? No. And that's totally fine. That's why I do it for effort. So we take a negative 1 out, and we're left with x minus 3. Just for warning you, I do walk around, and after this day, if you actually leave your entire sheet blank, that counts as a 0. That's the only way you can get a 0. So that's hardcore getting a 0. You just didn't do anything. All right. So This is all with my what? X, is it not? The negative 1 could still get distributed back in, isn't it? So it's all with my X. So I know that I'm going to have XY become something Y. Why did my Y stay the exact same? Yeah, because I have everything with my X. It's all with the X, isn't it? Is there anything here? No. Anything here? No. My Y is staying the same. Right? Then my X's are being multiplied by negative 1. And then I'm moving 3 to the right, so I add 3. So I have 110 is going to become negative 1 plus 3, comma 10. So it's 2 and 10. This one we have to graph the function below. We're graphing a function. We're moving a function. A function has points. We're moving coordinates, yeah?
4 and 10.
Nope. Negative 1 plus 3 is 2.
Oh.
I think you missed the negative. So we're moving coordinates, right? We're not moving just one. We're moving a few. So we're still going to use mapping. So we're going to add the 1 to the back. And we're going to get x, y becomes, this is the only thing with my x. So I'm going to get negative x, comma, and then I'm moving it 1 up. So it's y plus 1. So now I have to plug these in. So I have negative 6 and 3. That's my first one. Negative 6 and 3 becomes negative a negative 6, and then 3 plus 1. So it's going to become 6 and 4. Then I move to the next one. I don't just pick sporadic dots around. I'm going to go to the next one. The next one is at negative 4 and negative 3. Now I'm going to get minus a minus 4, and then negative 3 plus 1, which is 4 and negative 2. Now that I've done that, I connect them. I connect them right away. Then I move to the next one, which is 0, 0. And it's going to become negative 0, which is not real. And then 0 plus 1, so it's 0, 1. And then 4, negative 4 becomes minus a 4, comma, negative 4 plus 1, which is negative 4 and negative 3. Now, some people will tell me that this point here is invariant. What's the definition of invariant? Close, yep. Part of it, yep. A point that doesn't change. Same coordinate works. The problem is with the word same coordinate is people will tell me that's invariant. But it's not invariant because it's aggressive. It's not invariant because did that specific point not change? No, a different point changed to be on top of that one. Invariant means the point never moved. Is there any points on here that did not move? No, there's not one invariant point on this graph. That point still exists, but it's from a totally different point that it's there. So does the point still exist? Yes. Is the point invariant? No. Invariant means it was there, it didn't move, it's still there. Does that make more sense for invariant? Okay. We're going to turn to our notes to stretches. So last thing to learn, and then tomorrow they all go together. And it gets real fun.
I don't want to do stretches.
Actually, that's a lie. Tomorrow they don't all go together. Tomorrow we're reviewing polynomials. Wednesday's the test. Thursday they all go together. Correct. Yeah. You're going to have to learn them. Okay. Stretches of functions. Quiet, please. A stretch is a transformation that changes the size and the shape of the graph. The original and new graph are not congruent. There are two types of stretches, vertical and horizontal. The craziest part about the stretches is the sentence that you have to write. And you can't not write it correctly. You have to write it in the exact way it is. So, if I give you, let's say, y equals f of x, and I now give you transforms to y equals 3f of x. Whenever it's with the x, it's horizontal. Horizontal translation, horizontal stretch. Whenever it's not with the x, so outside of that bracket, it's a vertical translation, correct? And this is going to be a vertical stretch because it's outside of it. Do you see that? It's not with the x. So this is actually, this specific example, this is a vertical stretch, and you must write it this way. And if you try and translate it into a different way, it doesn't work. Vertical stretch by a factor of, and then this is where the number comes in, by a factor of 3 about the opposite axis of what you would think. X-axis. So just like the numbers in front, when they're with the y, it's a reflection in the x-axis. This is a vertical stretch about the x-axis. All the vertical stuff is about the x, all the horizontal stuff is with the y. Okay, so here it has the point xy becomes xay. So your mapping would be, for this specific example, xy would become x what? 3y. Your vertical stretches multiply your y's. So like I said to you, if it's in the bracket with the x, it'll affect the x in mapping. If it's not in the bracket with the x, it affects the y in mapping. So the outside stuff affects the y's, the inside stuff affects the x. Now, once again, the points on the x-axis are invariant. Why is that? We're multiplying our y's by something. Why would the same values on the x-axis stay the same? What are our y's on the x-axis? What are the y values on the x-axis? 0. When you multiply 0 by anything, what happens? It stays 0. So the points on the x-axis are invariant because they are x comma 0. And when I make x comma 3 times 0, it's still x comma 0. It didn't change, did it? So anything on the x-axis is going to stay the same when you're multiplying a y by a 0. So it's only the x-axis. And then if a has a negative sign, it doesn't affect the x-axis, or it doesn't affect the stretch at all. When the a value is negative, it's a reflection in the x-axis. We've already went over that. So your stretches are always with positive numbers, because the negative doesn't stretch it differently. The negative reflects it, correct? So for example, if I had y equals f of x, and then I had y equals negative 3f of x, this would be a vertical stretch by a factor of 3 about the x-axis, and the negative would cause it to be a reflection in the x-axis. The vertical stretch is not negative 3. You know that this negative here means there's a reflection in the x-axis, correct? So we write that in the reflection part, and this is a vertical stretch by a factor of 3 about the x-axis. There's never a vertical stretch by a factor of negative anything. If there is, don't pick that answer. It would be wrong. Because the negative doesn't stretch it at all. The negative just causes stuff that's going up to be down and down to be up. Right? So let's describe the transformations that occurred here from the graph of y equals f of x was y equals negative 4 f of x was y equals f of x. So what part of that is a vertical stretch? The 4 or the negative? The 4. So we have to start with stretches first, then reflections, then translations. So the 4, are either of these with the x? No, so they affect the y's, which means they're always about the x-axis. They're always about the opposite axis. So this is a vertical stretch by a factor of 4 About the what axis? Yeah, about the x-axis. They're always about the opposite. That's the 4. Now what does the negative do? Reflection in the x-axis. So we have here, given the graph of y equals f of x, use a table to sketch y equals 2 f of x. I'm moving coordinates. If I'm moving coordinates, what do I use? Mapping. Is this with my x? So it's affecting my y. And when it's in front, what operation do I do with it? Multiply. So this is going to be xy becomes x. Look, x is still by itself, so it's not changing at all, right? X comma 2y. So all my x's are actually staying the same, and my y's are being multiplied by 2. So I'm vertically stretching it by a factor of 2 about the x-axis. I'm taking all my y's and I'm going, now I'm doubling them. That's all I'm doing. So let's look at these ones. So I have negative 2, 0. Do it below. Negative 2, 0 is going to become negative 2, comma 2 times 0. Wait a second. It's negative 2, 0. Why did it stay the same? Yes, because my y value is 0 and I'm multiplying my y's by 2. So it's going to stay the same. This one's going to stay the same. Is there another one that's going to remain invariant? Yeah, this one here, 4, 0. Then let's try the next point. It's at negative 1 and 2. So it's going to become negative 1 and 2 times 2, which is negative 1 and 4. My y doubled. Does that make sense? I'm stretching it by 2. My y is doubling. Does that make sense? Yeah. So we do negative 1 and 4. Connect points. Then I have to do the middle one. It's at 1, 2, 3, 4, 5. Oh, it's right here. So I do 0, 5. It's going to become 0 and 2 times 5, which is 0, 10. Why did this one change? Negative 2, 0 didn't change, but this one doubled. Why is this one doubling? Yes, your y wasn't 0, your x was. And my x stayed the same, and I'm multiplying by my y's. So my y-intercepts change, but my x's don't when it's a vertical stretch. Do you see that? Now we're going to flip over once you're done. So here, they want us to graph y equals x squared. Say you don't even know what y equals x squared looks like. Well, y equals x squared, you could type it into your calculator, right? Y equals x squared. And then you can go second table and it'll give you coordinates, right? Second graph gives you coordinates. It'll tell you negative 2 and 4, 1 and 1, 0, 0, sorry, negative 1, 1, 1 and 1, 2 and 4. And I label it y equals x squared. Then they want me to replace the y with 3y. They want me to replace the y with 3y. So I have y equals x squared. But my y, I want replaced with 3y. So what does that mean when I replace? I take the y, I toss it, and I replace it with 3y. Is it helpful to me when it's not in y equals? What did I tell you we want to do first always? Get y by itself. So we have to divide by 3, which most people sit here and then stare at it for a while and they're like, is it with the x? It's not. If it was with the x, it would be in the bracket squared, is it? No. So instead of writing it like this, which makes it seem like it's with the x, when you just divide by 3, that's the same as multiplying by a third. So I put a third up front. I bring this and put a third up front because there's a 1 there. And then x squared. So what is it actually? Vertical stretch by a factor of 3, a third about the x-axis. But we're moving coordinates, so we want to use mapping. So xy becomes, my x is still the same. Square is supposed to be outside the bracket. Oh, good, it switched. Okay. So we get x comma 1/3 y. So I'm going to plug in 2, 4, or negative 2, 4. It's going to be negative 2 and 1/3 times 4, which is negative 2 and 4/3, which is just negative 2 and 1.333333. So we're at negative 2 and 1.3333. It's here. Then we're going to go negative 1 and 1. So we go negative 2, comma, 1/3 times negative 1. So we get negative 2 and negative 1/3, which is negative 2. Why did I put negative 1/3? It's at 1, 1, 1, negative 1, 1. Like it has to be positive. There we go. Negative. Why do I have a negative 2? There's so much. You were confused. In my head, this should be a 1. Negative 1. So it's negative 1 and positive 1/3. It's just above. Then 0, 0 becomes 0 and 1/3 times 0, which is 0, 0. It remained unchanged. So it is what? Invariant. And 1 and 1 is going to become 1 and 1/3 times 1, which is 1 and 1/3. And then this can be 2 and 1.3. We'll do that. Then we're skipping example 4 and moving down. No one asked why? I think the watch is dead. Super dead. I'm not even stepping if it's not calculating the steps. I don't think so. Might as well just sit down for the rest of it. Each from a chair. All right. Horizontal. Horizontals are flippers. So remember how horizontal, if it was x plus 3, it actually went 3 to the right? Horizontal stretches flip. So if it's 2, it's actually a half, because 2 is 2 over 1, so it's 1 over 2. If it's a third, it's a horizontal stretch by 3. It always is the reciprocal. People are like, when is it not? Never. It's always the reciprocal. They're like, but what is the unique situation? It's not. Whenever you take it out of the equation, it flips. When you put it into the equation, it flips. Words and mapping are the same. So if words and mapping are the same, we use the same numbers. So if I have bx, I'm going to use this I'm going to use this as a number because people get confused with this variable. So I'm going to say f equals 1/2 x. Let's pretend it's like that. It's with the x, right? So it's a horizontal stretch. It would be a horizontal stretch. By a factor of, when 1/2 flips, what does it flip to be? 2. Horizontal stretch by a factor of 2 about the what axis?
Y.
The y-axis. So it was about the opposite. And then my mapping for this would be xy becomes, what's my x's being multiplied by? 2. Because words and mapping use the same numbers. So if in words you're using a 2, mapping you're going to use a 2. Words and mapping the same. Remember I said this is very appropriate for today. Words and mapping are in heart. Same thing. If you use 2 in words, you're going to use a 2 in mapping. So I want you guys to do this one. Example 1. Describe the transformation that's happening. Go. So it's with the X, so it's horizontal. Just like horizontal translations, this is a horizontal stretch. By a factor of what? Yeah, because this would be 5 over 1, technically. Everything's over 1. By a factor of 1/5 about the y-axis. About the y-axis. Then we're going to flip over. So we have that graph just like we had with the stretches. Same graph. But this time we're going to apply the stretches that we have. So here we have y equals f of x, and then we have y equals 2x. So what's my mapping going to look like this time? xy becomes, it affects my x's because it's with my x's, 1/2 x. It's going to flip. 1/2 x. Anything happening to my y's? Out here or in front of here? Nope. So my y's are going to stay the same. So we're going to apply our mapping. -2, 0 is going to become 1/2 times 2, 0, which is 1, 0. Why did it move this time? Why am I using black? It looks the same. Why did this one move this time? I don't know what you're talking about. I drew it in the right spot and I didn't do it. Why did it move? Because it's, yeah, we're moving our x values and our y is 0. We need our x's to be 0 in order for it to remain invariant. So where are our invariant points going to be this time? When x is 0, which is where? When is x equal to 0? Which axis? The y-axis. That's where the invariants are going to stay. So this one's going to stay put up here. So we have -1, 2. It's going to become 1/2 times -1, 2, which is -1/2, 2. And then we have 0, 5. It's going to become 1/2 times 0, 5, which is 0 and 5. It didn't move, which makes sense, because when I multiply by 0, it stays the same. And then I have 4, 0, which is going to be 1/2 of 4, 0, which is 2, 0. Then we're going to flip over. Because we have the longer quizzes, we don't have enough time to scroll the notes. I'm going to flip over. They used to call it compressing and stretching, but now because they're being nice, they don't make you write the word. Okay, we're going to look here. Example 5. So the original is 4 minus x cubed. Do you see it? It's now, this stayed the same, didn't it? Is that the same? Do I have to describe anything about the 4 minus x cubed if it was what was there already? No. The only thing I have to describe is this 3 sitting in front. What do you think that 3 is sitting in front? A vertical stretch. By a factor of 3. About the x-axis. For B, what's the only thing that changed? Nope, the minus sign was there already. 4 minus x cubed. It's now 4 minus 2x cubed. What changed? The 4 is the same, the 4 is the same, the minus sign's the same, the minus sign's the same. The cube's the same, the cube's the same. That's the only thing that changed. The 2. What's it with?
Yeah.
So what is it? It's with the x. Is it a horizontal or vertical? That's a horizontal. So it's a horizontal stretch. If it's multiplied and it's with the x, it's a horizontal always. Horizontal stretch by a factor of, and then some people are like, well, now does it flip? What did I tell you? When you take it out of the equation, it always flips. There's never like a chance where it's like, oh, this time it doesn't. No, like it always flips. So when people don't, I'm like, this isn't the first time it's going to. Like it's never going to stay the same. So when you're going from equation to words or mapping, which are the same, it flips every single time. And you're like, well, when's the occasion it doesn't? Once again, never. It always flips. So when you're like, I wonder if I should flip it. Yes. Yes, you should. When you're taking it out of the equation and putting it into words or mapping, it flips. If you're going from words or mapping and putting it back into the equation, what's it going to do? Flip, right? Because they're the opposites. They're the reciprocals. They're the flip. So it's the horizontal stretch by a factor of 1/2 about the what?
Y-axis.
Y-axis. Example 6 starts putting them all together already, and I'm not going to make you do that. I'm just going to make you do the stretches so you can get that down. So, we will do example 6, just not at this very moment. We're going to do it on Thursday. Tomorrow we're reviewing polynomials. Thursday we're putting all of the transformations together, because Wednesday is your test. Okay. Just polynomials. The way that the February break fell, I wanted people to be able to write the test on polynomials and not try and remember polynomials and transformations after you come back. So I hit the polynomials before, and then I usually do them together, but I'm just not going to. Summaries only on polynomials, yeah. It's going to be due on Wednesday, when the test is. The day of your test is when your summaries have to be in my hand. I've already halfway finished my summary because I'm making one to show you what I would do if I'm making a summary, and I've taught this like 3 times at least a year since 2012. Mine's even color-coded. Pretty.
Do we hand the summary in like the same way we handed it out?
No, I could to take your summary.
I just didn't know.
You just show it to me. Yeah. I just need to see the summary, and then I give you a mark. It's a quick thing, like you did everything. 3 out of 3, you didn't. 0 out of 3, you kind of did. 1.5, like it's out of 3. So I just do a quick mark out of it. So if it's in a book, just show it to
Do we
me.
get bonus points? Using stuff in our summaries? Do we get bonus? I think we do. Transformations.
No, because transformations is a whole nother summary.
I only think that we did it.
Every unit is a different summary. So you've just completed a lot of your transformation stuff. That's good. You're just ahead of the game. Yep. No, each unit has their own transformation summary, and I give a mark. So you're just on you're ahead of the game. Okay. So page 20. Oh my gosh, my nose is so itchy. 29. Number 5AB. 6. 7AC. And then 9. Oh, I put it on the wrong.